Let z be equal to a plus bi be any complex number. Obtain an equation relating a and b given that the real part of z minus I over z is equal to 0. So z minus I over z is going to be a plus bi minus I divided by a plus bi, which is a plus b minus 1I over a plus bi. So if we want the real part, we've got to separate this out. So a plus b minus 1I over a plus bi, and let's multiply by the conjugate on the bottom, like so. And then we know the bottom of that becomes a squared plus b squared. Now, what's going to be, well, let's just expand it out. So we've got a squared, and then we'll have take away b minus 1I squared plus b minus 1 times a I, and take away abi. So the real part of z minus I over z is going to be a squared. Now I squared is negative 1, so it will be plus b minus 1 over a squared plus b squared. So that's going to be a squared plus b squared minus b over a squared plus b squared. So if the real part of z minus I over z is equal to 0, then we get a squared plus b squared minus b, which is the numerator here, is equal to 0. Okay, so let z be equal to r cis theta be any complex number. Obtain an expression for 2I over z bar. Well, of course, z bar would be r cis negative theta, because remember it's a reflection in the real axis. And so what we have is 2I over z bar. Well, I is cis pi by 2, so we have cis pi by 2 divided by r cis negative theta, and so that's 2 over r cis pi by 2 plus theta, because we subtract the arguments here. And finally, we want arg z plus r in terms of theta. So that's the angle of z plus r. So we had now that z was r cis theta. So r cis theta is here. The length of this is r, and this angle is theta. If we add r, it just goes this way, because r is just a real number, so it goes horizontally. And if I drop this down to here, what I have here is a rhombus. And so if we're adding this one to this one, the complex number we get will be this complex number just here. And because this is a rhombus, this splits the angle in two. So arg of z plus r is just going to be theta on 2.